12s, we are going to do a quick recap of our log and exponential unit here. Just to kind of, you can check this video out, watch it, and hopefully help you get ready for our test this week. Our test is going to be Tuesday. I will have extra help tomorrow at lunch, and I will have spent some time in class answering any questions that you might have about this unit. So we're going to what I'm just going to do is I'm going to kind of roll through quick each kind of section, textbook section here from the textbook, and kind of just give you a little recap of what happened in this unit. Okay, so first, I'm not sure why this is slow to load, but that's okay. So the first thing that we introduced is the idea that the inverse of an exponential function is also a function, and it is known as a logarithmic function. Okay, maybe, I don't know why that's not loading very well. Let's go here. Okay, and this was kind of our first key idea, our first lesson here, is that these two functions are inverses of each other. And then I went on to kind of show you the form or the change of form. So this on the left here, we have what's known as exponential form. And on the right, we have what's known as logarithmic form or log form. Okay, and that was kind of our starting point, is we want to know that, okay, inverse means opposite, and the inverse of an exponential, which you worked on last year, is known as a log function. And that was really just the focus of our first lesson there. And then we kind of got a little bit into sketching these, sketching the function and its inverse, noticing the reflections there, okay? And that was really one of the main things that we looked at, okay? One other really important thing that I do want to point out here when we were sketching this, because this will come up in about 2 to 3 minutes, is this point here in our inverse function, 1, 0. Notice how that's in both of my log graphs, okay? That 1, 0 point is going to be in every kind of base parent function of the log, okay? And that's going to be kind of a key point that we're going to look at in a few minutes. And that was really all we looked at. We looked at a couple key ideas, right? We have a log function has a horizontal asymptote, okay? Sorry, a vertical asymptote along the y-axis. So there's your vertical asymptote there, right? The domain and range we kind of analyze, but you can go through that note to kind of recap that stuff, okay? Then we got into, so our second lesson, we focused on transformations, okay? And we kind of went through, the old idea of, okay, vertical stretch, horizontal stretch compression, horizontal shift, and vertical shift. So we looked at that kind of those key ideas, which we've looked at throughout this course. And then when I was talking about transformations, I talked about two or three key things. Okay, kind of our anchor points, our anchor ideas. The first was that your vertical asymptote of a logarithmic function starts at x equal to 0, so it's always at x equal to 0. And when we shift our graph, our vertical asymptote is just going to be equal to our d value. So the VA is just always equal to our d value, okay? And that's always going to be the case. That's kind of one key thing to note. The second key thing to note is that our key point, or one of our key points, is the 1, 0 point. And all I asked you to do when I wanted you to sketch these graphs is I want you to know, A, what our base log function looks like, log base B of A. That's what, let me just change that. Where's my undo button? Oh, I can't see undo. There it is. Base B of x. That's basic log function. That's what a basic log function looks like right here. Okay, know what that looks like. The second thing is, if you know what that looks like, it's 3 steps to sketch a graph. Okay, your first step, and I go through them here. Your first step is, where is my vertical asymptote? Does that vertical asymptote move? It is what your d value is. In the case of this example here, my d value is -3, so my whole vertical asymptote is at -3. Then we look second at, where does the key point go? Now you do that using mapping notation, okay? So using mapping notation, where does my key point go? Okay, I just map that 1, 0 coordinate using mapping notation, my A, K, D, and C values, I get my new point. And then kind of the third point here, the last thing you want to know is your A value positive or negative? In this one, my A value is positive. So typically, and I'll just do a little sketch over here, if my a value is positive, my graph looks like this, right? So that's a equals positive. And if my a value is negative, well, what does a negative a value do? It flips your graph. My graph is going to look like this, okay? So you just also want to note what your a value is, if it's positive, if it's negative, so to see if my graph's going to be increasing or decreasing. And that's kind of a quick summary of how to sketch these. You will be asked to do a quick sketch on the quiz, on the test. Then we got into evaluating. Now with this, like, you can evaluate with a calculator, and that was kind of one of the key things that we looked at was, okay, how to do this with a calculator. I did a lot of these examples without a calculator. I'm not going to do examples right now, but if you would like to check out some examples or you have some questions, just send me an email. The one kind of real key thing in this one was your common log, and that's that fact that the expression log of x is called the common logarithm. It just means that you have a base 10, right? Log of x base 10 and log of x are the same thing, okay? Like I said, we did a whole bunch of examples here of kind of switching from logarithmic form to exponential form and then kind of solving for x there, okay? Now, there might be a little question like this, just kind of using some of the kind of key ideas here, and these key ideas would be these at the bottom here, okay? These 3 key ideas here, there will be a question on your quiz where you have to like solve or evaluate a log using these 3 ideas here. Okay, now those, I'm going to give you a formula sheet. You'll be probably given those on a formula sheet. Okay, again, practice the homework, go through the homework, look at the examples I've done in the lessons. But yeah, on this page here, we're really just focusing on, okay, how do I solve or evaluate what a log is equal to? Okay. Now, lesson 4, we got into our log laws. Okay, there are 3 of them. They are right here. The product law, which says that if I'm taking the log of x times y, that's the same as the log of x plus the log of y, so I can break that apart. If I'm doing the log of x over y, that's the same as doing the log of x divided by the log of y. And if I'm taking the log of a power, so log of x to the power of y, we can drop that exponent down in front and it becomes y times the log of x. Okay, so that's just a few, those are your 3 key log laws. You'll be given those on a test on your formula sheet, but you need to know how to use them. That's important. Okay, then we evaluated using these log laws. So I did, again, some more examples of how to evaluate using those log laws, how to first simplify and then answer those questions. Okay, there were some more extensive ones here where I asked you to just kind of write as a single log. There'll probably be a question like that on your test where I asked you to write as a single log. Okay, I'm going to continue to roll along here. We also, in this lesson, looked at the change of base formula, which is if I want to break this log apart, I can do that by changing my base to anything. In this case, I just pick the letter A. I could pick base 10, I could pick base 2, and I do the log of m base A divided by the log of B base A. And that's kind of a way to change our the look or appearance or the base of my logarithm. Okay. Again, some homework practice there. Let's now jump over to our last 2 and kind of our most important 2 sections here. These were the solving ones, okay? And you're definitely going to be asked some questions like this on the test. There's going to be a few of these, specifically in the application section. I'll talk more about the test tomorrow, but I am going to kind of give you a little info on this today. So in the first one, solving exponential equations, this is when you're given questions where you have x in the exponent, okay? So basically with this, you want to generally take the log of both sides. Taking the log of both sides will allow us to get our x down from the exponent, Okay, it's kind of like if I have a ball stuck on the roof, I need to go get a ladder out to go get that ball off the roof. If I want to get the x out of the exponent, I have to get my log out and take the log of both sides to get my x out of the exponent. Okay, there are several good examples here. I'm going to highlight E. Okay, in the past I've put something like E on the test, so that would be a good one to kind of look at. And I mean, not to say that none of these other ones could be on there, but E is usually a trickier one that I do put on the test, okay? There's 2 application type questions here. You will probably see a question like this on your test, an application style question, okay? So again, just kind of review those there. And lastly, the last thing we kind of looked at was solving logarithms. So now this is where you're given a log. Instead of an exponent, you're given a log. So in this case, we're starting with log, and we want to solve for x here. Now there were 2 kind of key ideas here. The first was that in A, if you have a single log on both sides, you can just cancel out your logs. So in A, what you'll notice is that I do basically have a log base 2 on both sides. All I end up doing is I cancel out my logs. That's extremely helpful, okay? So that's the first kind of type of question you could see. The second one is like B and C. In B and C, I have a single log on one side and a number or a value on the other side. When you have that, you use this formula here. You change it to exponential form. You use this formula here to change it to exponential form. Okay, that's the process for those questions. Okay, you can also use our log laws to combine. So notice in this one, notice in this one I've highlighted the plus. Okay, that's when we're going to use one of our log laws to simplify that first and then change to exponent form. And I actually do that in D, E, and F. So there's going to be one like that on your test, okay? Again, just some more practice questions here. Determine the x-intercept. I do like this question. This is a pretty good, like, kind of application question, okay, to kind of throw on there. But yeah, some good practice questions there. And that kind of just summarizes, a very brief summary of kind of what we did in this unit. But just kind of something for you to watch to just kind of wrap your head, get your head back into the swing of things. Now, if you have any questions today, shoot me an email. Okay, send me an email today. I am going to also post you'll see in this post here, the kind of the check-in. You can complete the check-in, kind of see where you're at, see how your understanding is of the material. And the review is also posted. Make sure the review is posted on D2L as well for you all. And that kind of goes through and summarizes everything. I will also post the breakdown of the test on OneNote, okay? So hopefully you all had a great Christmas break, holiday break, and we will see you all tomorrow. All right, have a good one.